Okay, so here's the solution, or my solutions, how to work through it for the review test from Friday. The first question, where we are given the graph of the velocity of particle A, and we are given a table of values for the position and velocity of particle B, measured in meters per second. Time is measured in seconds. Let's see. And they're differentiable functions. For particle B, position and velocity is differentiable. Very important if we are going to use some theorems. So here we go. First question, is speed of A increasing or decreasing at time t equals 6? Speed is the absolute value of the velocity. But to determine if speed is increasing or decreasing, we have to look at the value of the velocity in conjunction with the sign of the velocity in conjunction with the sign of the acceleration. As we can see from the graph, the value or the sign of the velocity at time t equals 6 is negative. So velocity is negative, but it has a positive slope, so that means the acceleration is positive. So at t equals 6, velocity of 6 is negative, acceleration at 6, or the slope of the velocity, is positive, so the speed is decreasing because the velocity and acceleration have opposite signs. So that's 1A. 1B, for how many values from 0 to 10 is the speed equal to 1 meter per second? Remember, speed is the absolute value of velocity. So that means we need to see where velocity, or how many times, that's all it asks for, is how many times is velocity equal to 1 or negative 1. It happens twice. We don't really care at what times, we just want to know how many times it happens. It happens twice. So the answer for 1B is twice, or 2 times. 1C, find all times at which particle A changes direction. Particle A changes direction when the velocity changes sign. So when the velocity graph crosses the x-axis. So it happens at 4, at 7, and at 9. Okay? All we care about are where it changes sign. Part D, total distance traveled. Here we go with total distance traveled again. This is by B. To find total distance traveled, we have to find our position at our endpoints. In this case, our endpoints are 0 and 5. And our position anytime where the velocity equals 0 and changes sign. And that happens at t equals 3. So there are our positions. And then we find the differences in consecutive positions. From 0 to 3 seconds, the particle traveled 13. It's positive, that's total distance traveled, we don't care what direction. So we went 13. And from 15 to 13, we went 2. Yeah, we went in the opposite direction, but we don't care. We just want total distance traveled, add up the 13 and the 2, and we get 15 meters. So be careful with that, okay? That got a lot of people. Part E, find the average velocity. Average velocity is the average rate of change of the position. So it's just position at 10 minus position at 0 over 10 minus 0. You could leave it at 18 minus 2 over 10, or write it in whatever form. For F, all times during which the two particles travel in the same direction. Travel in the same direction means the velocities have the same sign. I just made up velocity number lines for A and B. They're both positive from 0 to 3. Then velocity B changes, so it's no good. Then they're both negative from 4 to 7. And then they're both positive again from 8 to 9. So those are our 3 intervals. And that's all it asks for, is the times for which they travel in the same direction. They don't care what direction, just the times. Part G, which is greater, the average acceleration of A or the average acceleration of B? Well, we could look at our graph for A, and we're looking at from 8 to 10, and from 8 to 10, the velocity is decreasing, which means the acceleration is negative. So the average acceleration of A is going to be a negative value. We can estimate about what it would be by estimating our values from the graph. We don't really know the velocity at 10, but we know it's a negative value. Then for B, average acceleration is the velocity at 10 minus velocity at 8 over 10 minus 8 gives us 2.5. So the average acceleration of v is greater because it's a positive value. Average acceleration of a is going to be negative. The last part, and there was a lot in this question, and that's what they said, this 25-minute question, going to take a lot of time. Is there guaranteed a time? When they say guaranteed, that should kind of make some alarms go off that they're looking for you to use a theorem, either mean value theorem or intermediate value theorem. Usually mean value theorem, but let's see. Is there a time from 7 to 10 such that the acceleration of particle B is equal to 2? Well, we don't have actual values of acceleration, so we cannot use intermediate value theorem. We have to use mean value theorem because acceleration is the derivative of the velocity. And since they told us the velocity is differentiable, then the mean value theorem must hold true. So we do our mean value theorem, we get 2. So by mean value theorem, there must be a value c where the acceleration equals 2. So that was question 1 from practice test 2.